We're here in Vancouver, British Columbia at the SEI manufacturing plant. My name is Bambi Bucket, and I'm the Western Regional Manager for the Bambi Bucket product line. We build Bambi buckets in a number of sizes, all the way from 72 US gallons all the way up to 2,600 gallons. And a lot of the functions of the control mechanism, which you see here, a couple of examples, are basically the same inside. Most of the tips we're going to talk about here are for in-field repair. You're already going to have a spare Bambi bucket. This kind of stuff is critical when you're already on your backup bucket and you need to figure out some of these parts and how to change them as quickly as you can to stay up in the air. The key areas we're looking at are the intermittent problems. Those are the toughest ones to identify. And as a pilot, often the pilot will have the first indication that there's an intermittent problem, either a failure to release water or a failure to dump water. This is with buckets that are used for thousands and thousands of cycles. They get enough wear on them that they eventually start to show some wear in these components right here. Now again, if you're to test this bucket, this one here has a little bit of has lube, and this is a good demonstration of what lube tends to do to the solenoid pin. So here's the bucket full of water. The trip line is in this position. It's tight against the catch on the inside of this trip block, and it won't go anywhere until electricity is powered to the solenoid, and that solenoid pin moves in, trip line moves out, water's finished dumping, and it automatically comes back in and locks into place, ready for the next dip again. So this area with this solenoid pin, if you focus in here on the solenoid, you can see how slowly that solenoid pin is moving, and it's not moving nice and smooth. It should be snapping back in place, but that's the result of lubrication. It becomes gummy and sticky over time, and that'll cause either a failure to release the water or a failure to hold water at some point. That can be a cause of it. What the solenoid pin should look like when it's moving is more like this new one here, which has no lube on it, and it should be just snapping up and down. It should move very quickly. If you push it in, the spring kicks in and locks it back in place very quickly. So our first area of troubleshooting for intermittent problems is your wiring. Electrical. 9 times out of 10, if a bucket's not functioning properly, it's the electrical cable that's been broken inside the conduit jacket, or even inside the copper wires have broken inside there. This is an area that can cause problems because there's a strain relief here, and that wire tends to bend right at that point. So you want to check your wires first. If it's not this area, remove your long line. Remove the extension cord out of the equation, because by connecting this plug directly to the aircraft power, you're going to get a better indication of whether or not the bucket's working. And then you can focus on your long line and troubleshoot that area. Some of the stuff I talk about are lessons learned in the field, and one of the unusual situations that we saw in California in 2008 was the conduit jacket was intact, but the copper wire inside had actually broken because of too much strain being put on the electrical cable. So the helicopter would go up, the bucket wouldn't function. He'd come down on the ground, we'd test it on the ground, and it was fine. It checked out on the ground. He'd go up again, it wouldn't function, come down, it was fine. And someone who was able to troubleshoot that by putting a continuity tester on there actually had the foresight and smarts to pull the actual lead wire on the control head and found that it broke continuity when they put tension on it. So they realized that at some point it had been lifted up with not enough slack in the electrical cable, and that broke the wire inside. Very difficult problem to troubleshoot, and very, very annoying as well. But an easy one to keep in the back of your mind for future reference if it ever happens that you've got this strange situation of the bucket functioning on the ground but not in the air. So in this area here, in the control head itself, section 6 in the manual is excellent for troubleshooting all of these components, but again, you're looking for wear and burrs, uneven surfaces. that may show up on the swaging itself. There may be a knife end on the end of this bullet assembly. These three pieces we call the bullet assembly. So you're looking for any wide pieces on the swage. You can actually take a file to this and file down those shoulders on both sides. Especially if someone has replaced a trip line, there may be less tolerance in the barrel assembly that's here. So as the trip line moves in, you'll be able to feel if it's really sticky and grabbing inside the barrel. You'll take a look at these swages and see if they're shiny, and that's an area that you'll need to file off. On this edge of the bullet assembly, when this becomes worn over 8 or 10 years of service, some of these parts go through thousands, tens, hundreds of thousands of cycles, and that edge can become sharp as well. And it can, because it's steel, it can work itself into the cast aluminum block and create a ledge in there that every once in a while it's going to just grab on there and not let the bucket release the water. So that's something to look for as well. You're looking for gaps between these three parts as well. If you got more than a finger or two space between these three components, that may be too much slack, and it may cause that bucket to not work properly for you. The other area I wanted to show in detail here is we talked about how this trip line holds all the valve action in there. So there's a fair amount of water weight on here. It's not the entire weight of the bucket on this one trip line, or you'd have the purse strings and the trip line breaking all the time. But there is a significant amount of weight. And everything, as you can see, this part here, when I pull on that, it moves slightly. The point at which that catch lets go is when this corner here is allowed to move past this edge, and I'll push this out, overextend it here. There's an edge on here that locks into that corner. The top of this catch mechanism is here. It's very rounded off. It's still functioning, but normally it would have a very straight surface across there. No burrs on these edges. If there are burrs here, they need to be filed out and taken off, because that can cause it to fail as well. But this edge here mates up with this corner right here, and that's where everything happens. Every time it goes back in, it moves past that catch, and you can see the small spring action there as it moves past and then clicks into place, and it's locked. Your water's locked in there now. So we talked about intermittent issues. Failure to release water is one of the more concerning ones. Failure to hold water is a fairly easy one for the pilot to check right away while he's still up in the air. Simply by refiring the solenoid, you may free up some of these linkages. It can roll up in that kind of position where this end of the catch is on top of the roller bearing. So in that case, again, you'll be dipping into the water site, and there's nothing stopping that trip line and the valve from releasing all the water every time you go in to try to pull up a full bucket of water. So the pilot should be aware of these intermittent issues. As soon as you have an intermittent issue, it's not something to be ignored. You know, let your ground folks know what's going on with it. And that's the time to get into these parts here. And you can sometimes see this on the ground when you have the control cover off. It'll go into this position, and you know that you've got a weak spring here or a worn part here that's very simple to replace. But in the air, for the time being, for that day's operations, the pilot's first recourse is to refire that solenoid. And by refiring the solenoid, it'll suck the pin up and it'll roll. It'll give enough slack that'll roll and lock back into place.